So now we're moving on to higher order radicals, cube roots, fourth roots, so on and so forth. Just how we have in the past. We're just building upon what we've previously learned with adding in just a little bit something else. In this case, higher order and more complicated values under the radical. So with part A of this exercise, we're looking at the cube root of 27x to the 27th. So again, cube root, we want to know what perfect cubes can we factor out of here. So 27 we know is 3 cubed. So 3 cubed equals 27. And then with x to the 27th, we know that that is what, when it's cubed, equals 27. That's going to be x to the 9th cubed equals x to the 27th, and that's because 9 times 3 equals 27. So if we rewrite this with it factored out into perfect cubes, we're going to have the cube root of 3x to the 9th all being cubed. So we have an odd index being taken to an odd power underneath the radical, 3 and 3. We don't need to worry about absolute value, so our cube root is simply 3x to the 9th. The cube root of 27x to the 27th is 3x to the 9th, and that's because if you cube 3x to the 9th, you get 27x to the 27th. Part B, we're looking at the fourth root of 81q to the 28th. So again, even index, but we want to look at what perfect fourth powers do we have that are underneath this radical that we can factor out. Well, we need to recognize that 3 to the fourth power equals 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. And q to the 28th, q to the what power to the fourth equals q to the 28th. So what times 4 equals 28? 28 divided by 4 is 7. So this equals q to the 7th to the fourth power equals 28. We simplify what's under the radical, and we have the fourth root of 3 times q to the 7th. That's being taken to the fourth power. So we have an even index. We have an even power. We're taking it, the fourth power of something going to the fourth. And the exponent on the variable is odd. That means there's a chance that if q is negative, then q to the 7th is also going to be negative. And therefore we need to take the absolute value. So that would equal, we could say, the absolute value of 3q to the 7th, or we could simply say 3, because we know it's positive, times the absolute value of q to the 7th. You might also see sometimes where textbooks or lessons will factor the even q part out of the absolute value. So this, what would also be acceptable would be 3q to the 6th, because we know that's positive, times the absolute value of q. We just factored out the even powers essentially. But for purposes of this course, right now we're looking at, we would just use this, 3 times the absolute value of q to the 7th.